Hi, welcome to my video on MIPS. Today we're going to be working on calculating equations. And as you can see, we have this small equation right here. It says z is equal to 2x squared plus 3y plus 2. Now, what we want to do is we want to find the value of z if we are given the value of x and y. So let's pretend we know the value of x and y, and we'll pretend that x is equal to 3 and y is equal to 5. Okay, so what I'm going to do is I'm going to load the value 3 into register T0 and the value 5 into register T1. So I'm going to do a load immediate T0 3, load immediate T1 5. What this does is this puts the value of 3 into T0 and this puts the value of 5 into the register T1. Now in this equation we can separate it into 2 or 3 different parts. It depends on what you want to do. But what I'm going to do is I'm going to split it up into 2 parts. The first part I'm going to calculate 2x squared. So how I'm going to do that is I'm going to first square x. So how can I do that? Well, x squared is the same thing as t0 times t0. And I'm going to save that value into the register t2 since I haven't used t2 yet. So I'm going to do multiply. This is the register that I want to save it into, t2, and I want to multiply the value of t0 2 times. So what does this do? So it multiplies the value of t0 with the value of t0 and puts it in the register t2. So this is 3 times 3 and 9 should go into t2. Then after that we completed the x squared part, we need to multiply it by 2. So what we're going to do is multiply, and we're going to put the value back into register T2 again. So T2, and since our value of x squared is in the register T2, we're going to multiply the register T2 with the 2. So what this does is it multiplies the value that's in T2, and the value inside T2 is the value inside T2 is x squared, and we're going to multiply T2 by 2 and put that into the register T2. So now we completed the first part of our equation. The second part of our equation is 3y plus 2. So let's do the 3y part first. And what I'm going to do is I'm going to save the value of 3y into the register T3. So what I'm going to do is multiply. I said I was going to put it into T3. I'm going to put that value inside T3, and we don't need this comma right there. And we're going to multiply the value of y, and the value of y is stored inside register T1, and we're going to multiply it by 3. So 3y is this line right here. The value of T1 multiplied by 3 and put into T3. Now I need to take this value and add 2 to it. So I'm going to do add T3. I'm going to put the value inside T3 again. I'm going to add T3. I'm going to add T3 with 2 and put it inside the register T3. So what this does is it takes the value of T3, and the value of T3 is T1 times 3, that's this part right here, and we're gonna add 2 to it. Okay, and the final part is now I have 2 registers. The first register has this value, and the second register has 3y plus 2. So now the only operator in between those two things is a plus. So I'm going to save my final value into the register T4 because that's the only register I haven't used. So I am going to add, and I'm going to put this inside register T4. I'm going to add the values of T3 and T2. T2, like I said, is 2x squared, and T3 is 3y plus 2. And now our value inside T4 is the value of this function where x is equal to 3 and y is equal to 5. Now the cool thing about this is you can change the value of T0 into whatever value you want, and it'll still calculate this function depending on your value x and y. So say you change this to a million or 1,000, and we change this to 50,000, it doesn't really matter. It'll still calculate it and put the value inside T4. Now doing that, say through paper and pencil, it might be a little difficult, so doing it through assembly might be a little easier. So I'm gonna switch our values back into 3 and 5, and now the final thing I'm gonna do is I'm gonna print out the value that's in T4 or the value of our function onto our screen. So how can I do that? Well, the first thing I'm going to do is I'm going to move the value T4, because that's our function, that's the value of our function, and I'm going to put it inside A0. So now the value of T4 is going into A0. Now you might be a little confused why I'm doing that, but I'll show you in a bit. Then I'm going to do a load immediate V0 1. What that does is it loads the integer value 1 into the register V0. Now, and then I do a syscall. Now what does that all do? What that does is a syscall 1 is what I call it. A syscall 1, which is a syscall with the value 1 inside V0, what that does is it prints out whatever integer value is in A0 as a decimal. So whatever value is in A0, it'll print it out on the screen as a decimal number. And you'll see that as I run through the code and show you a preview of what's going to happen. So let me assemble my code first. Assemble. Okay, let's see what happens. Our first thing is inside T0 we put the value 3, inside T1 we put the value 5, and one thing to notice is even though that this says 3 and 5, these are in hexadecimal values. Okay, so this is hexadecimal 3 and this is hexadecimal 5. And the next thing is we're gonna do the we're gonna square 3 and put that into T2, and after that we're going to multiply it by 2 and put that value inside T2. And as you see here, the value is 0x12. Now I know that you know that 9 times 2 is not 12, it's 18. But like I said, this is in hexadecimal. So 0x12 is equal to 18. Now as we go on, I'm going to skip through some steps. Now the value of T3 is 0x11. That's our second part of our equation. And the value of T4 is 0x23. That's our 2y plus 2, I believe. And then into A0 we save the value 23. Now we're gonna print it out onto the screen as a decimal number, and if you watch on the bottom, it'll print out the value of our function, and that's 35. Now I know right here it says 23, yet on the screen it printed out 35. That's because this value is hexadecimal, whereas this value is a decimal number. The answer to our equation where x is equal to 3 and y is equal to 5 is 35, not 23. But 0x23 is equal to 35 in decimal format.